Hello, in this lecture we will find the radius of the small circle. In the drawing we have two circles with an internal lunge with each other. At this point we will define this point as point N, and we know that AC equals to 9 units, BD equals to 4 units, and this angle is a right angle, and also this angle is a right angle, and we want to find out the radius of the small circle. First of all, we will define the center of the small circle as point P, and we will define the center of the big circle as point Q. Okay, actually in the drawing we have three tangents to the small circle. This line segment is tangent to the circle at point L. So point L is the point of contact between the tangent to the circle and in the second step we will draw a radius to the tangent, and we have a rule that a radius is perpendicular to its tangent, so this angle is a right angle, it equals to 90 degrees, and also we have the second line segment that is tangent to the circle at this point. We will call the touching point between the tangent to the circle point M. So that is the radius of a circle, and we will also draw a second radius to the point of tangent to the tangent. So that is the radius. The radius is perpendicular to its tangent, so that is a right angle equals to 90 degrees, because the radius is perpendicular to its tangent, so this angle is a right angle. And then we will draw another radius to the third tangent. Let's call to the point of contact between the tangent to the circle point Z, and we will draw a radius to the tangent, so the radius is perpendicular to its tangent, so this angle is a right angle. So actually we have here two rectangles. So PM is the radius of the circle, so ZD is the side that is parallel to PM in the rectangle PMZD. So ZD also equals to the radius of the circle, and also LP is the radius of the circle. So actually we will define this point as point H. So HZ is also the radius of the circle, and we will define QZ as X. QZ equals to X. So actually CQ will be equal to R, or CQ will be equal to R minus X. Okay, here is point C. So CQ equals to R minus QZ, that is to say to R minus X. Okay, CQ equals to R minus X. So actually we will define the radius of the small circle as R, R is the radius of the small circle, and we will define capital R as the radius of the big circle. In the next step, we will calculate the value of capital R, that is the radius of the big circle, in two ways. We will calculate the value of the radius of the big circle from the right side, and then we will calculate the value of the radius of the circle, the size of the radius of the big circle, from the left side of the circle. Okay, so we'll create equation number 1 that express the radius of the big circle, and we'll calculate it from the right side of the circle. So the radius from the right side of the circle will be equal to 9 units, that is AC plus CQ, and we have already found out that the value of CQ is R minus X. So the radius of the big circle equals to r plus to 9 plus small r minus x. Okay, so equation number 1 is the calculation of the radius of the big circle from the right side of the circle. Equation number 2 will be the radius of the big circle from the left side. The radius of the circle from the left side will be equal to 4 units plus r plus x. Okay, the radius of the big circle, when we calculate it from the left side, is actually 4 units plus r plus x. X plus r plus 4 equals to the radius of the big circle. Okay, so we calculated the radius of the big circle in 2 ways. In the next step, we will compare question number 1 to question number 2. Both of them are the radius of the same circle, the radius of the big circle, so they are equal to each other, and we will get that 9 plus r minus x equals to 4 plus r plus x. Okay, that will be equation number 3. That will be equation number 3. Here we have r in this side of the equation, and we have r in the other side of the equation, so we can cancel r. What left after we cancel r is 9 minus x equals to 4 plus x. Here we will subtract 4 from equation number 3, and we will get that 9 minus 4 is 5. 5 minus x equals to 4 minus 4 is 0, so equals to x. Okay. Here we will add x to equation number 3, and we will get that 2x equals to 5. Okay, we got that 2x equals to 5. Here we will divide the equation number 3 by 2, and we will get the value of x. We will get that x equals to 2.5 units. Okay, so we actually found out the value of x, that is qz. X equals to 2.5 units. Okay, in the next step, we will implement a rule in our drawing. We have rule number 1 that states, according to rule number 1, if two circles have an internal lunge with each other, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, so I will read rule number 1 again. According to rule number 1, if two circles have an internal lunge with each other, then the distance between their centers is equal to the difference between the lengths of their radiuses. So we actually can implement rule number 1 in our circle, because in our drawing we have two circles with internal lunge between them. The internal lunge between the two circles is at point N. Therefore, we can implement rule number 1 that states that the distance between the centers of the two circles, that is to say PQ, because P is the center of the small circle and Q is the center of the big center. So the distance between the two centers is PQ, equals, according to rule number 1, the difference between the length of their radiuses. So the length of the radius of the big circle is capital R, and the length of the radius of the small circle is small r. So we will get equation number 4 that states that PQ, that is the distance between the centers of the two circles, is equal to the difference between the length of the radiuses of the circle. That is to say, PQ equals to capital R minus small r. Okay, PQ, this is the distance between the centers of the two circles, equals to R minus R. Okay? And we have already found out that actually according to equation number 1, we know that R, capital R, equals to 9 plus small r minus x. And we have already found out, according to equation number 3, that x equals to 2.5 units. Therefore, if R equals to 9 plus R minus X, we can substitute X by 2.5 units, and we will get that in question number 1 that capital R equals to 9 plus small r minus 2.5. Okay, so question number 1 states that capital R equals to 9 minus 2.5 is 6.5 or 6.5 plus R. So equation number 1 states that capital R equals to 6.5 plus small r. But according to equation number 4, equation number 4 states that PQ equals to R minus capital R minus small r. If we add to equation number 4 small r, we will get that capital R equals to PQ plus R. So actually we have the value of the radius of the big circle in equation number 1, that is to say capital R equals to 6.5 plus R, and we have in equation number 4 the value of capital R that is equal to PQ plus small r. So we can compare equation number 1 to equation number 4 because both of them are the radiuses of the big circle. Okay, and we will get that question number 5 that PQ plus R equals to 6.5 plus small r. Okay, we actually compared equation number 1 to equation number 4 because both of them are the expressions of the radius of the big circle, so they are equal to each other. And we got equation number 5 that states that PQ plus small r equals to 6.5 plus small r. Here we have r in one side of the equation and we have r on the other side of the equation, so we can cancel r. Okay, and after we cancelled r, we will get that the value of PQ is actually equals to 6.5 units. And we have already found out that X equals to 2.5 units. Okay, so if we join point P and Q by a straight line, then we will get a right triangle. Okay, triangle PQZ is a right triangle. PQZ is a right triangle. triangle PQZ is a right triangle because of the fact that this angle is a right angle, because we have already explained to you that the radius is perpendicular to its tangent, and at point Z we have line segment CD that is tangent to the circle at point Z, so the radius is perpendicular to its tangent, so this angle is a right angle, so triangle PQZ is a right triangle, and therefore we can implement the Pythagorean theorem in the right triangle PQZ. According to the Pythagorean theorem, in the right triangle PQZ, the square of the hypotenuse, that is to say PQ square, equals to the sum of the squares of the perpendiculars equals to QZ square plus R square. Okay, according to the Pythagorean theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say PQ square equals to QZ square plus R square. Okay, PQ square equals to QZ square plus R square. We have already found out that the value of PQ is 6.5 units and QZ is actually X, and X equals to 2.5. Okay, so PQ square is 6.5 square equals to 2.5 square plus R square, and 6.5 square is 42.25, and 2.5 square is 6.25 plus R square, and here 42 minus, we subtract 6.25 from this equality, and we will get that 42.25 minus 6.25 equals to 36. 36 equals to R square. Here we'll take a root out of this equality and we get the value of R. R will be equal, the root of 36 is 6, so R equals to 6 units. So the answer to the question is that the radius of the small circle equals to 6 units. Okay, the radius of the small circle equals to 6 units. Now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle and we know that AC equals to 9 units, DB equals to 4 units. This angle is 90 degrees and this angle is also 90 degrees. And we want to find out the radius of the small circle. Okay, First of all, we defined the center of the small circle as point P, this point, and we defined the center of the big circle as point Q, this point, and then we actually note that those two circles have an internal lunge between them, and the internal lunge between the two circles is at point N. They are touching each other at point N, and we have three tangents to the small circle. This line segment is tangent to the circle at point N. This line segment is tangent to the circle at point Z, and this line segment is tangent to the circle at point M. In the next step, we drew three radiuses. The first radius is drawn from point P to point L. So actually we have a rule that states that the radius is perpendicular to its tangent. For that reason, this is a right angle, it equals to 90 degrees. And also we drew the second radius from the center to point Z, exactly to the touching point between the tangent to the circle. So according to the rule that the radius is perpendicular to its tangent, this angle is a right angle, and also we drew the first radius from point P to point M, exactly to the point of contact between the tangent to the circle. So again, the radius is perpendicular to its tangent. So this angle is also 90 degrees. So actually we created here two rectangles. Shape PMZD is a rectangle, and therefore in any rectangle the two opposite sides are equal to each other. So PM is equal to ZD, and PM equals to R, so ZD is also equals to R. And also we have the second rectangle, that is the shape LPZC. LPZC is a rectangle because we have all the angles inside this shape are right angles. Therefore this shape is a rectangle, and we know that the two opposite sides, or the two parallel sides in any rectangle, are equal to each other. So NP equals to CQ, and LP equals to small r, so CQ also equals to small r. Okay, so we defined, so we know that LP equals to small r, so CZ it is equal to LP, so CZ equals to R. So if CZ is R, we defined QZ as X. We know also that ZD is also the radius, and CZ is also the radius of the small circle. So if CZ is the radius of the circle and QZ is X, then CQ will be equal to the radius of the circle minus QZ, that is X. So CQ equals to R minus X. Okay, then we calculated the radius of the big circle capital R from two sides. We calculated the radius of the big circle from the right side of the circle, and then we calculated the size of the radius of the circle from the left side of the circle. Okay, so when we calculated the radius of the circle from the right side of the circle, what is the radius of the circle from the right side? It is actually AQ. It is actually AZ, because Z is the center of the big circle. Okay, so what is the radius of the big circle? AZ. AZ actually equals to AC, that is 9 degrees, plus R minus Q. So I made a mistake. And the Q is the center of the big circle, and P is the center of the small circle. So AQ equals to AC plus CQ. AC is 9 units, and we have already found out that CQ is R minus X. So the radius of the big circle, when we calculated it from the right side of the circle, is actually equals to 9 plus R minus X. Then we calculated the size of the radius of the circle from the left side of the circle. What is the radius of the circle from the left side? It is actually BQ. What is the size of BQ? It actually equals to 4 plus R plus X. Okay, so BZ equals to 4 plus R plus X. So our second equation is the calculation of the radius of the big circle from the other side, that is 4 plus R plus X. So we calculated the radius of the circle in two different ways. So equation number 1 is equal to equation number 2, because both of them are the expressions of the same radius of the big circle. So equation number 1 is equal to equation number 2. We compare the equation number 1 to equation number 2 because they are equal to each other, and then in this way we created equation number 3. And from equation number 3 we found out that X equals to 2.5 units. That is to say QZ that equals to X equals to 2.5 units. In the next step, we presented a rule number 1, that states that if two circles have an internal lunge with each other, then the distance between their centers is equal to the difference between the length of their radiuses. So we can implement rule number 1 in our circle. We implemented rule number 1 in our circle because we have in the drawing two circles that have internal lunge between them at point N. They are touching each other at point N, so they have internal lunge between them at point N. Therefore, we can implement rule number 1 in this drawing. That is to say, according to rule number 1, the distance between the centers of those two circles, that is to say PQ, because P is the center of the small circle and Q is the center of the big circle, and the distance between those two circles is PQ, according to rule number 1, is equal to the difference between the length of the radiuses of those circles. that is to say PQ equals to capital R minus small r, because the distance between the centers of those two circles is equal to the difference between the length of the radiuses of those two circles. And the length of the radius of the big circle is capital R, and the length of the radius of the small circle is small r. So the difference between the length of the radiuses of the two circles are capital R minus small r, and that is equal to the distance between the centers of those two circles. That is to say PQ equals to R minus R, or capital R minus small r. Okay, that is from one side, but from the other side we have already found out that the radius of the big circle equals to 9 equals to 6.5 plus small r. Okay, so we have the radius of the circle according to equation, the radius of the big circle according to equation number 4 equals to PQ plus small r from one side, but from the other side we have already found out that the radius of the big circle equals to 6.5 plus small r. So we have the expression of the radius of the big circle in two ways. So they are actually equal to each other because it is the same radius. So we can compare equation number 1 to equation number 4. We compare the equation number 1 to equation number 4, and we found out that PQ equals to 6.5 units. PQ is the distance between the centers of the two circles, and it is equal to 6.5 units, and we have already found out that x equals to 2.5 units. Okay, we connected together by a straight line between point P to point Q, and we created a right triangle. Triangle PQB is a right triangle because this angle is a right angle, so triangle PQZ is a right triangle, so we can implement the Pythagorean theorem in the right triangle PQZ. And according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say PQZ equals to PQ square equals to QZ square plus PZ square, that is R square. Okay, according to the Pythagorean theorem, in the right triangle PQZ, PQ square equals to QZ square plus R square. And we know that PQ equals to 6.5 units, and QZ is X equals to 2.5 units. And the only missing variable here is R. So we solved this simple equation, and we found out that the radius of the small circle equals to 6 units. Again, the radius of the small circle equals to 6 units. Okay, thank you very much.